So how many in here have built a JSON API? And no, I'm not talking about your regular JSON API, which can be easily serialized to XML using this fine IBM product. No, I'm talking about the JSON API conforming to the JSON API specification. Anybody have used it? Some of you? Yeah? Okay, good. We'll go through it. So think about your average REST API. And in a REST API, we make changes to different URLs by using different HTTP methods. So we have the get, the patch, the puts, post, the deletes, and so on. And we perform them on different URLs. So the most basic JSON API could probably be designed like the traditional, in the traditional sense. Could look something like this, right? We do a GET request for an event with an ID, and we get back something like this, right? A model which has an ID, it has a title. And this is good. I mean, we can understand this, it's easy and so on. And say we want to get the attendees for this T.A.K.E Unconference in the future at the space station. We could do it like this. We just do another GET request to a new URL where we find the event's attendees. And here we find the partially famous Swedish astronaut, Mr. Fuglesang. But now we have like our first issue here, because I mean it's quite common that we maybe want to get the event and oh sorry. Okay, so hello to all of you new listeners turning in. Yeah. So basically, yeah, we have this endpoint for attendees, but now it's common we maybe want the attendee and the attendees at the same time, right? And so we may go on by doing something like this. So we just add the attendees into the event. So now we get the event and we get all the attendees at the same time. And I mean, this works really great. This is really neat. But okay, saying that we now want to include also the events the other events that these attendees are going to, right? Somewhere around here we start getting problems, because now we have circular references in our APIs. And it's somewhere around here that the discussions start. Like, how should we handle this case in our design? You maybe know of these meetings. And we start to discuss, okay, how do we do this? How can we solve this? And people have different approaches to this. And these discussions are kind of pointless, because this is kind of a solved problem, so we don't really need to have them. So enter JSON API. And what's really interesting about JSON API is that the 1.0 is to be released like today, and after 1.0 it's intended to be 100% backwards compatible. So the idea is that if you once have built a JSON API client, it should be able to read JSON APIs that are created in the future as well. So that's famous last words, of course, but it's, yeah, I like the effort. So okay, let's try and solve the same problem in JSON API, shall we? Okay, so our GET request to our event. So far so good. We haven't introduced much here. As you can see here, we have a top-level member called data. So data is what we use to represent our the primary data that's supposed to come out of an endpoint. So now we call for an event, and basically we expect to find an event in data. Pretty straightforward. And in data here, this is kind of a representation of the model, and which is called resource objects in the JSON API world. So a resource object always has a type and it has an ID. So by having its type and ID, we can always uniquely identify it, which I'll show you because it's really useful. And then here we also have some attributes. So yeah, this is a very basic model. So okay, let's say we want to add attendees to this. Or no, first I'll show you how just, I mean, if we would to get many events, we could of course just make data an array, because now the primary source we expect is of course many events, so then we will expect an array. Right, but okay, so now we add attendees to this. And now we have added another member to the resource object here. It's called relationships. And relationships is just a special kind of attributes. So you cannot find a member in both the attribute section and the relationships section, only in one of them, right? So here we see attendees. And attendees again contain data. But this time, in the relationships, data just represents a link to another object. So here we see it has a type and an ID. And as I said, we can always like reference a resource object by its type and its ID. And this is not the whole thing. We continue, so I couldn't fit all in one slide. So imagine this is the same data we get somewhere here. Now we've also added the included member. And we use included to add like data we want to sideload. So if data represents our primary data, then included will represent our sideloaded data. In this case, it's attendees. So here we can see another resource object with a type and ID and some attributes. And notice the relationships here. So here we're back referencing to the original event we got in the beginning. So, yeah, we kind of solved it. So I'll go on now and show you some more features that the specification has to offer. Now, what if we have a lot of attendees? How do we handle that? Or we don't want to, maybe attendee is a really big object, so we don't want to include them all the time. So then we can do something like this instead. So here, instead of sideloading the attendees, we've added something called links to the relationship. And this is also defined by the specification, what links should be. So basically, here we have a link called related. And in the related link, in a relationship, that's where we're supposed to find the whole resource object. So basically here we just get like the links to the objects, and by going to this URL, we can get the full objects. Okay? And now, this is something you'd regularly find in your documentation, right? You'd see in your documentation where you would get the attendees for an event. But now we embed it into the actual response, which actually makes the computers read the documentation instead of the developers. So that's one step closer to singularity, right? And I mean, this is also really cool because it makes it easier to change in the future. Like if I want to change the URL these attendees are located at, I can do that without having to like infer a new version to my API, notify everybody about the change, update the documentation. I just change it here. Okay, but what if we have like huge amount of attendees? Then we can add even more links. So we've talked about the related link, but then we also have the self link. And the self link is supposed to match the object you're at in the structure. So in this case, it's a relationship. So what you would expect to get back from the self link is actually the relationship links. So here you can choose between, do I just want to get the links, or do I want to get the full objects? And just getting the links can be pretty useful because actually you may already have loaded those attendees in memory. So you don't need to do another request to go fetch them. But if you want to, you know where the URL is. And I've also added a member called meta here, as you can see. And this is a namespace reserved for your use. Here you can put anything you like. So just demonstrated by putting count here that's a useful thing for just sideloading stuff you could need on the way. Okay, pagination. So whenever I see like a new JavaScript MVC framework or any new like hip web framework, I go by pagination to assert how mature they are. So if they have a good strategy for solving this, they may be mature. And if they even haven't got to this level yet, they're probably quite young and will have a lot of other bugs. So therefore, I thought I would show you how Json Api handles pagination. So okay, here we have a request for events. So basically, now we're just fetching all the events from a system. And now, instead of returning all of the events, we return some of them together with some links. And you recognize a self link, but we've added some more links here. And these links are also specified in the specification. So whenever a client encounters these links, the client knows that it deals with page data. So basically, it could page it for you. Or you could say, I want this many events, and it will page them until you get that many. So by doing this, you kind of add a new layer to the APIs. You make them more discoverable for a computer. Yeah. And here I've also added just some to show you how you can use metadata. Just adding count, how many there are per page, and which page we're at, and stuff like that. Okay, so we've talked a lot about reading. So I thought I also would show you some basic CRUD operations. So how would you go by, for example, creating an event? Well, that could look something like this. Really simple. We just post kind of the same resource object we've been looking at all the time, but we post them instead of getting them. And here you can also notice the MIME type. Json API has actually their own MIME type, which is a registered real MIME type. So whenever you encounter this MIME type, you know that you have a JSON API you're dealing with, which is really useful as well. And for updating, JSON API doesn't use a put request in any way. You're meant to always use patch requests, because as you may know, the semantic difference between patch and put in HTTP is that a put request is meant to create or replace a resource, while a patch request is used for making partial updates of a resource. So you can use this to update relationships and attributes and whatnot. So, JSON API has a lot of cool features, and I will just show you some of them here, just to give you idea of the cases people have been thinking of. Some of you may know of the JSON patch format. It's another format. It's an RFC, and it's meant to handle stuff, handle updates in another way. So let's look at how adding a photo could look when using the JSON patch API. Now, basically what we have here is a patch request to photos. And instead of actually just sending down the resource object we have, we wrap it in another level. So this is a JSON patch object. And here we specify an operation called add, a path, and that's just JSON patch format for saying this path we're at right now. And then we put the resource object inside value here. And now notice this is an array. So what this enables you to do is to batch up a lot of different operations in one single request. And since they're specified as operations, you can also distribute them really easy. If you have lots of shards, for example, you can just send out these changes to all of them, and you'll have your data in sync. So I'll show you how you go by if you want to change something in one of these objects, right? So again, we do a patch request, but this time notice that the operation is a replace instead of an add. And we're targeting actually a path inside of our resource. So now we're targeting source inside of an actual photo, and we set it to a new value. And what's interesting about this is that we can actually use this to make undo redo functionality as well. So it doesn't only gives us the ability to distribute it amongst several systems. We can also reverse all these operations, since we have them in a series. So this is a really useful way. And the JSON patch format is a so-called extension to JSON API. So they're basically, right now, there are two official extensions. There's the JSON patch format, and there's the bulk updates. And then you can see here, in the MIME type, we specify which extensions we use. So it's really easy to see there what we use and not. Okay, so as I said, JSON API, of course, contains much more than what I've covered here. It also gives you the tools for how do you represent errors in your APIs, and how you go by updating relationships between different data models. So I hope now you start to see what I mean by the use of actually conforming to specification like this. Because this actually gives you freedom to focus on the stuff that actually matters, and then you can rely on a specification to have solved these basic issues for you, instead of you having to solve them over and over again. And then you also get the intelligence on top thing by having a self-discoverable API. And this is kind of in the lines with hypermedia APIs, if you heard of that thought, which is basically like an API should work like a web page. It should have links, and you shouldn't need to like when you go into a web page, you don't know all the URLs on that web page. You don't have a documentation for it. You just click the links, and then you come to different places on the page. And if the page updates or changes, you change the links, right? Okay, so how would you actually go by doing this? It sounds good and all, but how would you actually implement this in a project? So I'll warn you right away. As I said, I organized the Nordic.js conference, which means I also write a lot of JavaScript. So the examples here today will be in CoffeeScript. So yeah, basically, Nordic.js, the conference we are arranging. It's not only a conference; it's also our whole QA system at Confetti. So we use Confetti as our kind of test event. So we try out new features, and we build a lot of stuff for Nordic.js, which then ends up in Confetti. So instead of testing stuff for our customers, we're testing it on ourselves. And when doing this, we found out that it was quite useful to be able to build lots of smaller applications, or microservices, or what you want to call them, but basically lots of small web apps. So for instance, we would need like a web app for handling check-ins when people come with their tickets and we're supposed to check them in, which is a good fit to put in an app of itself. And then having an API like this really makes that super easy, because you can just point the client to the endpoint and then start coding against that API. So therefore, we have like also open sourced a library called Json, which we use for both like serializing and even reading from the JSON API. So I'll show you how we use this in our projects. And basically, this is what it could look like at the client side of things. So here we have the we require JSON, and we create a JSON store. And now we have some kind of service where we get the event, we get back the data, and then we just sync it down the store. And then the store will handle everything for us. It will set up the relations, it will understand the data. So now we can do like find request in our store. And what we get out is the event with the attendees already there, serialized for us, without us having told this client anything about our API. The only thing that it knows is that it has got data from somewhere. So I think this is really cool, because this makes the whole creation of APIs and the whole like dependency graph between APIs much better. Okay, so how would this look at the server side? We've introduced something we call presenters, and a presenter is often representing a model. So we just send in our models. The presenters don't know anything about ORMs, or it could just work with basic JS objects or whatever you want. And then we make a presenters, which like defines what's the relationship here, what should the type be, does it have any special attributes and stuff like that. And as you see here, we kind of like link presenters together. So the presenter tells like which presenter should I use for which relationship. And this is a quite handy concept, because this means that we can also like use different presenters for different use cases. So maybe at the admin side, we'd have a presenter who exposes much more, and on the just like public user side, we can have a presenter that hides some attributes. And this is all isomorphic JavaScript. So it works just as well in the server as it does in the browser. So I thought I'd pause there and see if you have any questions so far. And I'll do it like this. I have some Nordic.js merch here, some 3D glasses, and I also have one of those nice Nordic.js hats and some bags. So I'll reward you for questions. Okay, so the first question will get a hat.
the relation with for this custom media type related to the other popular formats like JSON, HAL, Siren, or I don't know, maybe also collection JSON?
Yeah, that's a good question. Actually, they claim to take like a bigger approach than HAL, for instance. But I also think like this is a very lightweight approach if you compare it to other stuff I've seen. But it still handles most of the differences. But I mean, of course, there are other formats which like does basically similar stuff. This is the one I found most useful. But I mean, I'm sure that there are other implementations that could be just as good.
You also find popular libraries in many languages, for example, for implementing JSON HAL or something like this.
Yeah.
And it's kind of the same approach as you showed today. And
yeah.
I was wondering why the need, why the...
Yeah. Well, basically, it takes a wider approach. It covers more cases than JSON HAL in specific. And Json API also has a lot of different implementations. So you basically find the implementations in many languages. They have a list on the page with everything. That? Okay, next question. Get a tote bag? Any takers? If I add 3D glasses to that? 3D glasses? Bag? For a question?
If I have my object graph, so I have my domain model. I have to describe all the structure with data relationship every time for each domain model object, or does it handle it for me?
So the question is, if we have like an ORM layer which already describes all of these relationships and attributes and stuff like that, do we have to describe that over and over again? Now, in our approach, we wanted to make it ORM agnostic. So we basically didn't want to tie it up to a single ORM, saying like, for this ORM it should work like this. But we've also made it in a way that it's our implementation is quite extensible. So it's quite kind of easy to adapt it to the ORM you want. So this is just like the pure basics, and it will be very easy to like make it actually read from an ORM and read up all the relations. But I think like you could also be careful in a way with doing that, because just because you have the data model doesn't necessarily mean you want to expose it to the public, right? So there's kind of a danger in like just tying it directly to your ORM, and it's quite it could be of value to specify those relations we want to serialize and those we want to hide, right?
Thank you.
Okay, we have another question.
How would you tackle the situation when your client wants like your API to look in a certain way, but then you know that it's not correct? For example, we had like a sort of user ID that was present in another system, and the client asked us to actually insert some data from that other system, call that we had to make in our system, and present the data as a whole, so the data from our system and from that system to the client. Because his reasoning behind this was that their network connection might be faulty, or it might be slow, and then making two requests might be to others. How would you handle these situations?
Okay, so the question is how do we handle when we want to like make fewer requests?
Yeah.
Basically. Well, I'd say with JSON API it's fairly simple, because you can use the included section, and you can include lots of data there. But basically, I mean, it of course maps up URLs to models. But I mean, of course, you can add, say you have a search, for instance. Then data may contain, it doesn't maybe only contain events. Then it can contain, I don't know, everything you can search for in the system, and it could be a mix of different models. So I mean, you aren't like tied to having just a single type of models in your requests. And what I probably do, like if you mean the client has specific requests on the API, which would like break the JSON API rules, then I'd probably make like some kind of a proxy or some kind of an API that transforms their calls to the format that we want. So we don't like pollute our main API with their specific requests. Then it's better to have some transform mechanism that handles that, and maybe that transform mechanism could have a cache or something to solve issues like that. Because I think it could be dangerous if you let your clients have like too much influence in your API design, especially if you have many clients, because then you would like quickly run into problems. Which client should you listen to when?
So does that included attribute mean that it should not be loaded unless needed, or what's its actual purpose? Or why is it included and not something that's within that data structure?
So you mean how you can like limit different attributes and what you return, or?
Yeah, I mean, what's the rationale behind included? Why was it named that way? And why? Because you send the data, so the amount of data is the same basically.
Yeah, but basically how you could use included is like think of it, it's data that's the important part, and then we also add included because we know you may be interested in some more data. So this is quite similar. Think of it as a web page where you, for instance, have like different caching strategies for links, like fast loading something because you know that, well, the client will probably soon be going to click on this link because we just presented them this. So that's kind of a similar strategy, but in the API instead. So we try to look ahead and see like what could they possibly be interested in. And what's cool about this is we could change that. I mean, if we see that we have a lot of clients first asking for an event and then asking for the attendees, we could actually start including the attendees in the request, and then they wouldn't have to go make that extra request. So that's kind of the rationale behind having the include. Okay, bag and glasses for you too. Okay, we have one more question, and then I'll sum up.
You mentioned pagination, if you can go back a couple of slides. It's part of the standard, right, the specification. Is it in the responsibility of the producer or the service API, the part of page count and the number of records? So do you serve this data paginated as a part of the server or the service, or is it in a way requested specifically by the client, this pagination? Is it, because I know it's standard, so you're saying it's part of the specification. How does it work in the specification?
Okay, so the question is like how does the pagination work? Is it the API who decides what gets paginated, or is it the client that decides? And basically, it is the API. I mean, the API, of course, you can have like query parameters specifying how many you want per page. But the default is like and I think some of them are defined actually how you could work with that. But the basic idea here is actually that the API can decide how big of a payload you should get. Because imagine that this is a huge data set, and the client cannot know if it's huge. The client has no idea if will I get back like 500 megabytes or will I get back like almost nothing. So that's why it makes sense for the API to decide. So 3D glasses. Yeah, you can get them here. Okay, I think I sum up. I'll be around so you can ask more questions. Yeah, so that was really good questions. So I just thought I'd sum up a little bit what we talked about. Get yourself a future-proof strategy for your API design. In my opinion, I think you can get that by using, for instance, Json Api. There's probably a lot of other ways as well, but I think it's an important thing. That you don't just start out and let it evolve, because APIs can become quite messy to change. And try to end these pointless discussions in your projects and focus on like the important stuff instead, things that actually contribute value. And please go try JSON. I'd love your feedback or your pull requests, anything. I've added some useful links here. And it's a JSON API link, the link to JSON, Ember.js data, which is the original implementation, Orbit.js, which is like a patch, JSON patch format implementation, which is really interesting. And then please, if I could ask for you of just one thing, that you'd give me some feedback on this link, and on this door also, I should mention. But if you all could like take up a phone or something right now and visit this link. It seems to work? Yeah? Okay, very good. Thank you very much.